For this tutorial, I'm going to give you an overview of UrSA, the Infrared Science Archive. UrSA is one of the biggest archives housed at IPAC. UrSA has a huge amount of data. It includes all sky surveys in 20 bands, over 20 billion rows of catalog data, over 18 million images, and over 100,000 spectra. It contains data from many, many different missions. Many of those missions are infrared missions. From UrSA's front page, there's two different ways that you can quickly search. One is just put in the name of the object that you want, the radius over which you want to search, and ask it to search. It will go through all of UrSA's holdings and identify which data sets cover the region of sky that you've put in. It takes time to populate the page, but as you scroll down, you can see all the catalogs that it found in that region and all of the images that it found in that region. To investigate the images, hit the Go button, and it loads the images that it found into one of UrSA's tools so that you can investigate it. We'll go through more of this interface in a minute, but for the moment, let's go back to the UrSA page. You can also search catalogs from the front page. Because UrSA has so many projects, you first have to tell it what broad category of catalog you're interested in. Then, it'll take you to a page from which you can choose the specific catalog that you want to search from within that category. There are quick access buttons here for catalogs, images, a tool called Finder Chart, and the Virtual Observatory Application Programming Interface. Probably you won't be too interested in the API interface, but if you're writing programs to go and pull data from UrSA, this is what you need to use. The buttons down here have to do with all of the missions whose data are housed here at UrSA. The big missions are Spitzer, WISE, Herschel, Planck, TUMAS. IRAS and Cosmos are other big data sets. There are also data from a CARI balloon mission called BLAST, a ground-based data set called BoloCam, IRTS, ISO, MSX, PTF, and SWAS. Finder Chart provides a good way of interacting with many of UrSA's data holdings at once. When you first load Finder Chart, you're dropped into a search page. You can put coordinates in any of a variety of units, or you can type in a name and have Ned or Simbad resolve it. Here you specify the image size that you're looking for and the display size of the results. Using this tool, you can access data from the Palomar Observatory Sky Survey Digital Sky Survey, Sloan, TUMAS, WISE, and IRAS. You can also search the catalog at the same time. Let's turn that off for now. I've put in M101. Let's search. It comes back with data from DSS, from Sloan, from TUMAS, and from WISE. If you want to create 3-color images right away, click on this icon here, and it creates a 3-color image at the end of each row using bands from the corresponding row. So this is a DSS 3-color image, a Sloan 3-color image, a TUMAS 3-color image, and a WISE 3-color image. If you want to change which bands are plotted, click on the image to select it. You see it's outlined in orange. Go over here, click on that icon. By default, it uses WISE 3 for red, WISE 2 for green, and WISE 1 for blue. If you want to change it, pick the different image and load, and then it changes the color plane that it uses. You can also use this tool to search for catalogs at the same time. If you turn on Search Corresponding Catalogs, you can search within the entire image boundary that you specified, or you can search within a small radius. Let's search within the image boundary. Now it's got the images up here and the catalogs down here. Despite the fact that there is Sloan data here, it didn't find any Sloan point sources. It found some TUMAS point sources, and it found some WISE point sources. If it had found any Sloan data, it would have been overlaid on the Sloan images. The TUMAS data are overlaid on the TUMAS images, and the WISE data are overlaid on the WISE images. These catalogs are interactive, so that if you click on the source in the image, it's highlighted in the table. You can also make plots from this catalog. If you click on the plot icon, it changes the catalog view to a plot. To make any of these things big, click on the expand arrows to make it take up the whole screen. To change what is plotted, click on the gears. You can type in then names of columns in the catalog and do simple mathematical manipulations to make it plot. If you forget what the columns of the catalogs are, or you don't know them in the first place, click on the Calls link and it brings up a pop-up that has a list of all of the available columns in the corresponding catalog and a quick summary of what they mean. Let's type in W1M Pro for the y-axis. Apply. This is a color magnitude diagram, but it's the reverse of astronomical convention. Astronomers like to plot magnitude, such as the brightest things are at the top, but those are also the smallest numbers. To fake it out and make it plot that direction, plot minus W1 MPRO. Apply. There's the color magnitude diagram for the catalog of objects found in the M101 image. Many other of Ursa's tools also have the same look and feel. For all of the missions housed at UrsaWise, you can click on the icon and you get dropped into a page that looks basically like this, where you have a link to the most commonly used tools at the top, as well as the documentation, and then information about the mission and different tools and data deliveries corresponding to that mission. For Spitzer, let's go to the Heritage Archive. You can see that it has the same look and feel as Finder Chart. You do the same sort of thing. You can put in a source, have Net or Simbad resolve it. It echoes below the box what it thinks you've typed. You have a search radius, and you choose the kinds of products that you want to look for. Search. Here it's come back with a list of all of the observations near M16. These are all the mosaics and spectra that it found in the Spitzer archive in this region. I can also get reduced data from the IRS Enhanced Data Products, where I can interact with the spectrum here. For some regions, there's also super mosaics and a catalog. There are also contributed products in many Spitzer regions. In this region, we can find data from two different teams, MIPSCAL and GLIMPS. We can find images and catalogs. For more information about these things, you can click on the More Information links, or you can get just a definition of the columns. Once you load the catalog into the tool, you can interact with it as you can with any other catalog. You can sort it, and it gets overlaid on images that it finds. Let's explore some of the other data sets at UrsaWise is an all-sky survey. Its interface, again, looks very similar. You type in a position or a name. You put in your search parameters. In this case, let's get all WISE data, not all sky data, all 4 channels. Search. It goes away. It comes back with data from all 4 WISE channels, 3.5, 4.5, 12, and 22 microns. As for the other tools, you can search in catalogs and overlay the sources on the images that you get. You can also interact with the images and the catalogs by clicking on sources and images, clicking on sources and catalogs, or making a plot of the catalog. UrsaWise has other data sets as well. Herschel was a pointed far-infrared mission. Planck was a very long wavelength all-sky survey. TUMAS was an all-sky survey in the near-infrared. IRSA was an all-sky survey with bands between 12 and 100 microns. Cosmos is a survey that studies one specific region of sky, trying to understand galactic evolution. As for the other missions, you can interact with the images and spectra or search the catalogs. There's a documentation section of the UrsaWise website that collects all of the documentation on all of the tools and data sets that we have. There's also video tutorials that collect all sorts of videos, short and long, that describe UrsaWise services or highlight specific capabilities.